Welcome to my presentation. In this presentation, let us solve the system of linear equations, this application problem using matrices. This example, let us solve this example. If the sum of two numbers is 154 and the difference of the same two numbers is 38, what are the two numbers? So to solve this, we will try to write them out in terms of system of linear equations, and then we will solve those system of linear equations using matrices. Okay, so the sum of two numbers, let the first number, let the two numbers be x and y. Let x and y be the two numbers, According to our problem, the sum of these two numbers, x plus y, is equal to 154. That is one equation. And then the difference of those same two numbers, x minus y, is going to be equal to 38. And that is our equation number 2. And we have, in fact, formulated the system of linear equations right away. In step number 2, we're going to write an augmented matrix based on this system of linear equations. We're going to pick up the coefficients of x and y from equations 1 and 2 and then write the augmented matrix. The coefficient of x is 1 in equation 1, the coefficient of y is 1, and the constant term is 154. In the second equation, the coefficient of x is 1, and in the coefficient of y is -1, and the constant value is 38. So we have written out an augmented matrix successfully for this system of linear equations. And what we want here is we want ones along the diagonal, not a -1. We want a positive one there, but we want the values below the diagonal to be equal to 0. So therefore, we want this location to be equal to 0. And to achieve that, we're going to use the row operations to be able to get that. So to perform the row operations, we do this: 1, 1, 154, and then in the second row, the new R2 is going to be equal to negative R1 plus R2 So 1 minus 1, this will be equal to 0. 1 minus 1 plus 1, that will be equal to 0. 1 plus minus 1, this also 1, this is actually -1 here. -1 plus -1 will be equal to -2. And then this one here will be negative 154 plus 38. That is what we have, and that is going to be equal to negative 116, like that. Therefore, if we were to write it out in a clean manner, this is how it's going to look like: 1, 1, 154, and then 0, -2, negative 116, and that's the separation line. And what we need now is a 1 in this location. We already achieved a 0 below the diagonals, so to achieve a 1 there, we're going to perform the row operation as follows: 1, 1, 154, and the new R2 is going to be equal to existing R2 divided by -2. So 0 divided by -2, that is going to be equal to 0. -2 divided by -2, that's going to be equal to +1. Negative 116 divided by -2, that's going to be equal to positive 58, because negative divided by negative is a positive, and therefore if we were to write this in a clean manner, this is what we have: 1, 1, 154, and then 0, 1, 58, and then from here we should be able to find the values of x and y from this point on. So along the diagonals we have ones, and below the diagonals we have zeros here. Therefore we should be able to write the augmented matrix from here. The final augmented matrix is that we should be able to write the system of linear equations from here, and then be able to solve for the value of x and y. So x plus y equals to 154, that is our first equation, and then y equals to 58. This is our second equation. In fact, we have an answer right away there in the second equation. So we're going to back substitute this value of y into this first equation and find the value of x. So x plus 58 is equal to 154. Therefore the value of x is going to be equal to 154 minus 58, and that's going to be equal to, that value is going to be equal to 96. The value of x is going to be equal to 96, and the way we can interpret this solution is as follows. The solution is x equals to 96 and y equals to 58. The value of x, the first number, therefore the first number is 96, and the second number is equal to 58, and we got both the values, and we should be able to check our work from whatever we got here. So to check our work, we can go back and then substitute it into the given original equations which we formed. We said the sum of two numbers, x plus y, is equal to 154. The value of x, what we've obtained, is 96, and the value of y, what we've obtained, is 58. Therefore when we add them up, that should add up to 154. 96 plus 58 is 154. That is equal to the value what we have on the right hand side. Therefore the value on the left hand side is exactly equal to the value on the right hand side, and therefore the two numbers what we found is exactly correct. It also satisfies the second equation. This is equation number 1. It also should satisfy the second equation, and we said the difference of those same two numbers, x minus y, should be equal to 38. And the first number, the value of x what we have is 96. The value of y what we have is 58, and that should equal to 38. When we subtract 58 from 96, we get 38, and that is exactly equal to what we have, the value what we have on the right hand side. Therefore the value on the left hand side is exactly equal to the value on the right hand side, and therefore the two numbers, the values of these two numbers which we've obtained is exactly correct. So this is the way we can solve system of linear equations using matrices, and this is how we're going to apply the concepts of system of linear equations and apply the concepts of matrices to be able to solve these application problems. In my next presentation, we shall look at some more examples related to solving system of linear equations, and then applying matrices to solve those system of linear equations.